If you haven't seen my video on terraforming Mars and the 8 essential self-replicating units needed to convert an outpost into a colony, please do so. The rest of this will make more sense. As I mentioned in those videos, when the 8 sections are duplicated to a sufficient level, we will begin to work on terraforming. The first thing we will need to do will be to heat up the planet using greenhouse gases. Sulfur hexafluoride is the strongest greenhouse gas, which is so dense it acts the opposite of helium if you breathe it in. You can see in videos linked below. However, if we wanted to make a super heavy atmosphere to mimic the Earth's gravity to prevent medical problems from low gravity and atmospheric pressures, perfluorides may be a better option. Sulfur hexafluoride is an insane greenhouse gas that would require to be 46% of the atmosphere to make Mars the same pressure as Earth, but could only make up 1% of the atmosphere unless we all wanted temperatures like that of Venus or Mars. Perfluorohexane, or C6F14, could be in the ranges of 12 to 13% of the atmosphere, have 80% of the pressure of Earth's atmosphere, and the temperature of Earth. This is a fascinating chemical that becomes supersaturated with oxygen in its liquid form, and you can essentially drown an animal in it and it will breathe under the liquid. Doctors are investigating using it as a life-saving treatment when supercooling patients to stop damage. To begin with, we'll have to start pumping enough of it out to warm the coldest parts of the planet, the poles, to above the temperature to freeze dry ice, or CO2. Since the poles warm around 10 degrees for every 1 degree at the equator, we would need to raise the planet's temperature by about 11 degrees Celsius. This will give Mars a somewhat thicker and denser atmosphere than the gravity of the planet alone, so at night we won't get coated in dry ice, and the dry ice at the poles will now be purely in gas form, so it can be used to grow plants that sequester carbon. At that point, with all the CO2 flashing from dry ice to gas, the greenhouse effect will naturally take over, warming the planet the rest of the way until we start growing plants and sequestering that carbon in the soil and producing breathable oxygen. After that, we'll produce perfluorocarbon gases at a controlled rate until we reach the desired temperature as CO2 drops off. The biggest problems then will be our lack of water and soil. We can grow plants to convert CO2 into plenty of oxygen, but only if we have the water and nitrogen needed along with a nice loamy soil. Nitrogen on Earth makes up about 78% of our atmosphere and is essential for most plants we rely on for food and energy. It is in the air and still wasn't readily available for farms until we figured out how to make it chemically. New studies show that plants can grow in Martian soil using special techniques and blend of things like vermiculite, but we will need to mine for nitrogen-rich minerals to blend into the soil. Over time, that nitrogen will evaporate into the air with heat, changing the makeup of the atmosphere. However, we have no idea how much water there is on Mars. Thanks to the weak magnetic field over billions of years, hydrogen may have been stripped off of the solar winds, like Venus, and we may have to import water. The asteroid belt is filled with asteroids, each with their own collection of chemicals, one they found to have the same amount of water as Earth. We are currently working on missions to tow asteroids into various orbits and Lagrange points, and they will take at least 50 years before it becomes just standard practice. The easiest and quickest way to change Mars would be to tow a water-rich asteroid and let them crash into the planet, and we probably will just do this for smaller ones. However, by the time we decide we want to do this, we may decide that crashing an Armageddon-sized asteroid into Mars, while cool, may not be the best thing for the people living there, and it may have long-term negative impacts on weather that we were hoping to do more controlled. Also, no one could be on the planet for the heat of the crash generated, and the face of the planet would be unrecognizable, and a lot of the science would be gone. Instead, we would probably park a large asteroid in orbit and have robots mine it for water and nitrogen, and probably other good metals, and perhaps, if the physics worked out, use a propulsion mechanism to hurl multi-ton chunks of ice and nitrogen-rich rocks to burn up in the atmosphere without negative consequences, and they could use that motion to lift and adjust their orbit to keep themselves stationary. This could take decades, if not centuries. Another thing we'll have to do is to get rid of the radiation, which will allow maybe 5 hours above ground for an astronaut each day to get their full exposure of radiation. One proposed idea is to put a small high-iron asteroid into Lagrange point 1 and build a giant solar or nuclear-powered electromagnet on it of about 1 to 2 Teslas, and that should deflect most of the radiation, getting Mars down to Earth-like levels. This is actually a really good idea to do for Earth to protect us from solar flares that could seriously mess with our electrical and electronic systems if we get a really bad flare. When the ice caps melt, people will live near lakes pretty much exclusively, where the majority of the released water will hang out. At first, we will farm almost exclusively indoors to prevent nitrogen from escaping, though we will take in Martian air for its CO2, and then, when we have too much of it, release pure oxygen as the carbon will be used to make up plant cells. Any dead plant will be used to compost and make loam to build topsoil. Much of our algae will be grown specifically for loam, though we probably will grow seaweeds, duckweeds, and cress for good fast-growing veggie nutrients, as well as plastics and other algae-based chemicals. After that point, and after we have mined enough nitrogen nutrients, we will begin to generate the rarest items, soil and atmospheric oxygen. One of the most complex things about Earth that we would die without is soil. Earth's soil took millions of years to cover our planet. We'll try and do that in several decades in certain areas. If left alone over thousands of years, we would be getting some relatively fertile soil from moss breakdown of rock and dying and trapping of sand-loving plants all on its own, but we will be wanting actual soil much quicker than that. We'll start stocking the lakes and later oceans with algae, microbes, and plankton. This will quickly develop and trap carbon and silt, and some ponds we will be able to drain and use for soil elsewhere. Mars has mostly sand and clay. The sand is filled with perchlorates, which are toxic to most things, and mostly used as rocket propellant on Earth. We may harvest the soil for propulsion to get us off planet for returning to Earth at first. Just 0.5% in the soil is deadly to humans, but it may end up being a positive to help us build soil with the right genetically modified bacteria or fungi. For topsoil, we'll probably start with dried algae bales similar to hay bales you can plant things in. We'll fill it with soil microbes, worms, and other ground bugs to compost, as well as fertilizer, spray, and after a few years, you'll have loam to cover the sand and clay. The insects may not have enough oxygen at first, but the perchlorates may be a good source of oxygen, as a chloride with 4 oxygens bonded to it. If we can play it right, we can seed the bales with soil microbes that break down the perchlorates under the bales, oxygenating the bales for the insects, leaving harmless chloride salts when the bale is broken down enough to become soil. We will then grow plants with deep roots and surrounded with sandbags to prevent erosion, and you can begin to slowly expand outward. This will begin to oxygenate the planet until you can begin to release animals that can naturally fertilize the ground and spread seeds and soil. Dirt farming will be the biggest crop. Once that's done, the planet will be truly habitable. Populating with small animals only was at first what I thought we would end up doing, like birds, rabbits, goats, maybe wallabies, maybe letting it be a haven for endangered Australian animals and letting them evolve as the ecological niches get sorted out, and may have been the best option for transport. However, there are some serious experiments on artificial wombs that may completely transform what we can and can't take to Mars. We may just be able to take frozen fertilized cells of horses from Earth or even mammoths and grow them in a bioreactor womb, allowing us to populate the planet and then let them loose. We'll be able to populate this new ecosystem like an artist on a canvas and have no species on the planet we don't want until space travel gets so normal that smuggling and invasive species become a thing. I hope this was informative, and for all I know, there may be way better things to do that we'll figure out in the future than what I recommended. But with modern technology, this is probably the best ideas out there right now.